Hey everyone, welcome back to another DNA Masters tutorial. Today I'm going to be showing you guys how to fill out the coding potential section in the annotation process. So if you guys remember, we're going to actually use the GeneMarkS Meg PDF that we downloaded earlier. I showed you guys how to get that. So if you don't remember, I would definitely recommend checking out a previous tutorial. I'll leave that link in the description so you guys can download your file before starting that. Alright, so here's my file for the phage that I'm working on. What we're going to do is, since we're working on gene 23, we're going to look at the start site here, and it starts at 19,265. So we're going to find that number here on the GeneMark coding potential output number. So we're looking for 19,265. So here are the numbers, by the way, if you haven't been able to tell. This is just a 6-frame translation. The top 3 are in the forward direction, the bottom 3 are in the reverse direction. So we're looking for 19,265. Okay, here we go. Just to double check, 19,265. All right, so 19. Each big dash here is 100, represents 100. So this is 19,200. This will be 19,100, 300, 400, 500, 600, etc. So we're looking for 19,265, which will be about here. This would be maybe the start site. Just in case, just a reminder, these upticks are ATG start sites, and the smaller upticks are GTG, and then the smallest, or the down ticks are stop sites. So alright, so we found our start site here, 19,265, so a little bit more than halfway. This is probably our start site here, and let's see. Our start site is indeed GTG, so it'll be the small tick here. Let's zoom in even further. And there we go. Alright, it's really close. So this will be our start site, this little tick right here, and let's find our end site will be here because that's the closest one, and we'll see if that just about matches. So 19,933, and that's pretty close because this is 20,000 here. So 19,933. So our gene goes from here to here, and what you're seeing in the middle is the coding potential. Now I'm going to zoom out really quickly. If you don't see any spikes for your start site in any frames, so like if they all were blank, you may not have a gene at that location. It may be evidence that the gene reported by those sources when you ran auto annotate were incorrect. But that would just, mean you have to do more evidence. Perhaps look on a different output in terms of, this was SMEG output, but you could do a TB output on PhagesDB and try to see if that had any coding potential, but it would just be a kind of a red flag. But since we do have spikes here, we have some nice coding potential, little regions here that goes all the way from our start to stop site. We would say that this includes all coding potential because all the spikes and all the graph, all the little area under these spikes are fit in between our start site and our stop site. So this would be a good example. We'll go down here into the coding potential and we'll say contains all coding potential, output GeneMarkS. So every time you do this, you need to note what type of output you did. Since mine was SMEG, I put output GeneMarkS, which stands for SMEG. If you did TB, you would put output GeneMarkTB, and so on. You just note that to the QC annotator. So let's say, for example, if this spike extended out here past our start site. So if say if our start site was this here, this is a better example. If our start site was this ATG uptick right here, we would obviously have the wrong start site according to this graph because all of the spike area is not included to the right of the spike or in between the start site and the stop site. So in this case, if this was our start site, we would say does not capture all coding potential, and we would reconsider our start site, and maybe we would find that in fact it was this one. So again, this will help you try to find your real start site for your genes, but ultimately you want to take this coding potential data. Once you find it, if your gene doesn't include all coding potential, I would definitely recommend comparing it to homolog phage genes and seeing where their start sites are, because they probably had similar outputs here in this GeneMarkS file as well. So just the red flag if your coding potential isn't all included. So that's pretty much it, guys. It's a very straightforward process. Just to recap, the spikes represent coding potential. If you see no spikes, you may have to reconsider if that's a true gene, and maybe try changing your outputs. If you do have spikes, make sure they're all included in between your start site and your stop site, and make sure you find the correct start sites and stop sites before analyzing these. If all of the coding potential spikes are not included between your start and stop sites, as if this was our start site, we would reconsider our start site to maybe push it back further so that it would include all coding potential. That's pretty much it, guys. Hope you enjoyed and I hope you learned something. If you have any questions, as always, leave them in the comments and I will get to them. Thanks for watching. Have a good day.